is talking about anything else. Okay, let's talk about this question. Alright, this is very important before I start going over the question. Your grade 11 cycle geometry and your grade 12, they are going to be combined from now on. Okay? So you won't be answering questions on cycle geometry on its own. It will be a combination of grade 11 and grade 12 together. Okay? So in this question, you are expected to apply what you did last year to answer this question. And it's on similarity, similar triangle. Okay? As I told you earlier, proving that two triangles are similar is not that complicated. Use the names of the triangles to guide you. You don't have to get confused. So if you look at this diagram with all the stories that are there, right? There is a tangent. Okay? There is a tangent in the question. This is very important. That should be a clue to you that maybe you might need to use the tan chord theorem. Okay? Because that's the most common one when you're answering this question, the tan chord theorem. That's the most common one. So, what are we supposed to prove? Alright, here we need to prove that triangle EBA, that is EBA, is similar to triangle ECB. Okay? This is ECB. That is ECB. So we want to prove that those two triangles are similar. Now, what do you notice? Sorry, what did you notice first, even from the name of the triangle? They share what? Common angle. Or they share a common vertex, but we are talking about angle, so the proper answer would be the common angle. So we say in triangle EBA and ECB, okay? I can't remember. I have to go back, that's not very important. Alright, number one. Number one. So I'll say angle E is common. No, it's not the revision exercise. Right. Angle E is common. That's number one. Number two. Now let's do it angle by angle. We have proved already that this E here and that E are common. Okay? They are a common angle. Then we need now to prove the relation between this angle, that is B, which in EBA means we are talking about that angle. How is that angle equal to this angle C? Which C in ECB, this angle here? How are those two related? We don't have, listen, we don't have a diameter. There's no diameter. Alright, listen. Since it's going to be difficult to prove that those two are what are equal, that is C2 and ABE. I'm going to try and move on to angle A, which is this one here. Right? If it's complicated to prove that the pair of angles are equal, try the third one. The good thing is I've already proved that the first pair is a common angle. So angle A, this one here, in EBA, this angle, I need to prove that it's equal to this B in ECB, which is that angle. Okay? Is that possible to prove that B3 is equal to angle A? Is it possible? Yes. Yes, it is. Tan chord. Okay? So, I'm going to skip this B and skip that C, and then I'll write this down. Okay? So, I'm going to write it as, remember, it's EBA, so I'm going to write it as angle A. Make sure you're very careful about the correct triangle from which the angle belongs to. That's very important. So, because I skipped this B, I moved on to A. Which A? It's EAB. Okay, I can call it angle A. Okay, let me call it EAB. To be more specific, is going to be equal to B3. There isn't time code here. Okay? Now remember, it's not easy to prove that angle ABE is equal to C2. So the only way that I can prove that those two are equal is by saying, number 3, I'm going to say angle ABE, that is ABE is equal to C2. This is based on sum of angles in a triangle. Okay, so from here I can now say, therefore, triangle EBA is similar to triangle ECB. And my reason triple A. Then I'm done. Okay?
So, sir, for the 10-foot theory, we're going to have to identify where AB or substance.
No.
Okay.
Right? Any question? Usually, if you prove that two triangles are similar, the next question requires that result. And it will be in most cases on the ratios of the corresponding sides. So I prove that triangle EBA is similar to triangle ECB. The next question now is going to be very easy. I'm going to show you just now. Can I move on to the next page? Alright, we'll move on to the next page. So on the next page, I've already done this. Okay, I now need to prove that BE squared is equal to AE times CE. That looks very scary, okay, but it is not. It comes from 4.1. I proved that those two triangles are similar. So the first thing that you have to do, you write the ratios of the corresponding sides. So here I'll say from the names of the triangles, I can say EA, okay, EA over EB is going to be equal to BA over CB. So I say EA and EB, then I'm gonna have EB over. If I say EB, that will be over EC. Why is this true? It's because of similar triangles. Okay? Remember, you did this in grade 8 and 9. Okay, it's been a while, yes, but you did that. Now check this. This is very important. Always, when you're answering these questions on similar triangles, if they ask you to prove that two triangles are similar, always remember that the question below, in most cases that is close to 100%, is related to the proof you did at the top. They will never ask you a question from nowhere underneath a proof like this one. Do you get what I'm trying to say? Everything has got a connection. And if you get that, I can tell you, if you see this question, you'll be smiling. In actual fact, I've come to a conclusion that geometry is not that easy. It's not like that difficult. It depends with your perception and also what you hear people talking about. This is so simple. I proved that those two triangles are similar. Was that difficult to do? Huh? It was not. So now, check this. After writing these three ratios, you go back to the original question. Let the question guide you, as I said. From now on, always remember those words. When you're answering geometry questions on similar triangles, proportion, let the question itself guide you. You see here we have got BE squared. You see that? We have got AE, we have got CE. If you look at our ratios, We have got AE here. AE is the same as EA. We have got EB, which is the same as BE. Right? This one here, there's no relationship with our question. Do you see that? But we have got EB, that's EB there. We have got EC, which is the same as CE. So all I have to do is equate the first ratio and the what? And the last ratio. So I'm going to rewrite the EB as BE, the EA as AE, and the EC as CE. So the next step, I can do it on top here. I can do it there. Then I can say, therefore, AE over BE is equal to BE over CE. Okay? Then I'll cross multiply. If I cross multiply, that's how you can create the BE squared. So I'll get AE times CE, which is equal to BE squared, which I can rewrite as BE squared is equal to AE times CE. And then you are done. When you are doing the question, let the question guide you. Don't be nervous because you saw BE squared is what AE times CE. Some learners, when they see this BE squared is what AE times C, the brain will shut down. But it's so easy. It should make you smile, actually. Yes, it should make you smile. It should make you smile. It should not make you nervous. In actual fact, the question itself must be nervous of you now. If the question could talk with you to say, please don't solve me. Okay, let's see. I think for today, let's take a break.